Hello guys, so this is another question that I was able to solve in the contest 207, but yeah, I'm not sure whether or not this is a good solution, but here it goes and hope that my solution can help you. So the problem that we have here is to split a string into the max number of unique substrings. So let me explain. We have this string in here and we want to take substrings inside it and make them, well, let me explain it again. We will grab each character and form substrings contiguously. Okay, so the size of the word, we will not rearrange the letters or anything like that. Okay, with the word as it is, we will break it in substrings. Hope this was clear enough. So you can see in here the first example was like the biggest number of substrings that we can have from this string is 5. Outcome is 5. The definition is here. Okay, first substring is A, second substring is B, second substring couldn't be A again because it's not unique, okay, because there is already an A here, so we add B to A, and B is unique indeed. So next we have C, okay, C is unique. So next we have C again, it's not unique, so we need to extend it, and by extending it we found a unique word. Okay, so this is kind of the process, and you can do the same in here. Like A is unique, we had it. B is unique, we had it, and A is unique again, but we cannot add it because as a word, because it would be repeated. So we have to backtrack and do BA. Okay, and by using backtrack word, you kind of understand what we are going to need. So okay, so the answer here is 2, and here the answer is 1, because if you divide these words, you will have 2 A's, so the second A is not possible, so we backtrack and we add 2 A's. Okay, so next, so okay, by these examples I thought a little bit on them, and for me it was instant that this could be a greedy solution, but I was wrong. Okay, this is not a greedy solution, and I will explain why. So what I have thought was that we could greedily select always um, the smallest string, and increase if we found already that word. So here it would be like greedily get A, it is unique, greedily get B, it is unique, greedily get A, it already exists, so expand, we get B is unique, so we move forward, and then we get C is unique, then we move forward, C is not unique, so we extend, and we get a unique word again. And I thought that this would be a greedy solution, and I thought that this would fit perfectly. So it wasn't the case. There are edge cases where there are cases in which this reasoning doesn't apply, and we can find an example in here. Okay, so let's do this algorithm. So age is unique, M is unique, D is unique, uh, D again is not unique, so we extend. DA is unique, so D is not unique. DA is also not unique, so we have to backtrack. Okay. So let's try dead. Dead is unique, and we can try then A, and A is unique. So this would have a result of 1, 2, 3, 5 unique words. But actually we can do better if we do it like this: H, M, D, D, A, D. Oops, looks like I missed the example. I missed the example. I missed the example. This is also what a fail. This also works. This works also. So let me try with the B here. Let's check how it would go with the B. So 1, 2, 3. So let's. I'm sorry, this was unexpected, but let me test. 1, 2, 3. Mm-hmm. And now let me try. I'm doing it. So 1, 2, 3, 4. 1, 2, 3. So 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6. Okay, I'm sorry, guys. I cannot find the example in which this algorithm doesn't fail. I also couldn't find it while doing the question, but the thing is that the case exists, and I stumbled upon it during the contest and verified that actually this was not the solution. So the solution was indeed to calculate all possible combinations and just pick the biggest of them. Okay. So I will show you the code that makes that happen. As you can see, it was not a fast solution. Okay. So first of all, we will have a set that has the unique strings. We will have a max variable to have the maximum value, and we will have a recursive solution which takes a start position, an end position, a string, and here I added previous valid, which means that the previous word is valid, and this is useful to find the end of the string in the end of the string processing if we need to update the maximum or not. This is the base case. When we get to the end of the string, if the previous word was valid, we update the maximum variable. Then we grab the string between the start and the end, and we check if it is contained in the set. If it is not contained in the set, it is valid. So we add it to the set, and we will try the next character. Okay, so supposing that the word is ABA, we will pass in A, we will add A to the set, and we will try B. Okay, we will try B, and B is also valid. We will add B, and then we will try A. Okay, we will try A here, and B is true, is valid. That's what we are passing here. And then when we get here, we check A, and we see that we already add A in the set. So we do the alternative path, which is expand. Okay, so we try A, we try B, we try A again. A fails because already in the set, so we'll try to expand. So we are here, but we cannot expand because we already are in the end. No, we can expand. So we expand it, and we get to the base case. Okay, we are starting from a position that no, I have committed a mistake here in the explanation. So I start, so we are in A, we will expand A, and E, and we will do n plus 1, and this end is bigger than the length of the string, so we don't do it. We don't expand, we cannot expand. So we go back to B, and we go back to B, to this line, and B, despite B is valid, A is not valid, so we have to remove A. We have to remove B, I'm sorry. So from here we will try all possible combinations starting with B. Okay, so we will expand B and try BA, and that's what we do here. So in here we try BA. BA is unique, so we add BA. We try to add something, the next character to BA, and we go to the base case, and as BA is unique, the previous is valid, so we update the maximum and we return. We return, we remove BA, and we will expand BA. Okay, so after expanding BA, we go back because we cannot expand anymore, and we will try to expand AB because we end up here. We remove A and we will expand A. So we start at A, then B, then C, and do this all over again. Okay, so this is basically the solution, and I know it could be cleaner, but this was it. Okay, I enjoyed this problem. It was a backtracking problem, but I had some trouble figuring out how to implement it correctly, doing what I want, because despite of all, it was a little bit out of the usual patterns of backtracking, and that's always fun and a test to your understanding and learning process. So that was it, guys. It was a little bit confused, but hope you got the picture.